Welcome to Andowski Lectures. The topic is self-inductance and mutual inductance. Now, you can see a coil of conductor, which is an inductor, and a current passes through the inductor, which produces some EMF. Now here we say that when a current passes through the coil, a flux linkage is produced, that is phi L. And flux linkage is actually the rate of change of current multiplied by inductance, that is L into I. Now flux linkage is also a number of turns into magnetic flux, that is phi L equal to N into phi. So we can write N into phi is equal to L into I. From that, finally we derive at a formula self-inductance equal to N phi by IL. It means if a current of 1 ampere flowing through a coil produces 1 Weber of flux linkage, then that coil is said to have a self-inductance of 1 Henry. That is L equal to N phi by change in current. So we have arrived at the formula for self-inductance. And next we will look at the induced EMF. Now induced EMF E, from the formula is we can calculate the induced EMF from the self-inductance itself, minus Li equal to minus N phi, we know. And according to Faraday's law, E equal to number of turns into d phi by dt. And according to Lenz's law, induced EMF equal to minus N into d phi by dt. Because the induced EMF opposes the current, and that's why the negative sign comes. So fundamentally, a coil is said to have 1 Henry of self-inductance if the current in it changes at the rate of 1 ampere per second, inducing an EMF of 1 volts in it. This is from the formula E is equal to minus L into di by dt. That is, di by dt is a change in current and L is a self-inductance, and the induced EMF is the self-inductance multiplied by the change in current, or the number of turns multiplied by change in magnetic flux. To make it clear, I will explain it once more from the beginning. A current flowing in the coil, it decides the flux inducing. There is a flux induced in the coil because of the current. So flux proportional to I. Then self-inductance L, is flux per current. So if there are N turns in the coil, then L equal to N phi by I. This is how we get N phi equal to Li. Now differentiating the equation, the both sides, d by dt of N phi equal to d by dt of Li, which we get N into d phi by dt equal to L into di by dt. So we arrive at the EMF equal to minus L into di by dt. Di by dt is a change in current. Now, as a result, self-inductance may alternate be defined as EMF induced per unit rate of current change within the coil minus the EMF induced per unit rate of current change. That's also another definition. The SI unit of inductance is Weber per ampere or Henry. Inductance is in Henry. Next, we will look at the mutual inductance. We have gone through the self-induction part and found the EMF generated. Next we will see the mutual inductance. In mutual inductance there are two coils. So the current in coil 1 induces a current EM induces an EMF in coil 2. Now see the diagram. You have N1 turns. N1 is a coil 1. Phi 1 is a flux generated in coil 1. L1 is the self-inductance of coil 1. Similarly, N2, Phi 2 and L2. L2 is the self-inductance in coil 2. So there is an induced EMF in coil 2 by coil 1, and there is an induced EMF in coil 1 by coil 2. So the mutual inductance is actually the same. So ability of the first coil to produce an EMF in the second coil due to the change in the value of current or flux of the first coil is called mutual inductance. And you get the formula for mutual inductance as N1 into flux divided by current. So mutual induction in first will come as N1 into phi1 by I2. Current change in the second causes the mutual inductance in first. Similarly, current change in first causes mutual inductance in second. Let's see the mutually induced EMF, the value of, let's get a formula for mutually induced EMF, which is minus M into di2 by dt in coil 1, and in coil 2 is minus M into di1 by dt, and which both are equal because the mutual inductance caused in both are the same. So the formula is given M equal to N1 into phi1 divided by I2, or M equal to N2 into phi2 divided by I1. So the current change in coil 1, current change is basically induced using a switch. I have not drawn the full circuit diagram. Current change by switch, again there is a current source also. Now here we are just trying to find the mutually induced EMF, which is minus M into di1 by dt. Now let's do a simple problem, very simple problem of self-inductance. So self-inductance is given, the rate of change of current is also given as 300 ampere per second. You have to find the EMF. Now, using the formula L in di by dt, we get the value as 9 volt. And the second question, the current di and dt are given. So, using the formula, you can find the final answer is 5 volts. It's a simple answer. So, I hope you understood the concept of self-inductance and mutual inductance. Thank you for watching my video. Thank you.